Okay, hi, Assalamualaikum and good day. Welcome back. Hope you guys have a nice 1 week away from UTM. Okay, we're supposed to have a class today, but I'll be working away. So I hope that this video is sufficient enough to cover the syllabus for this week. Okay, pada minggu ke-9 dan minggu ke-11, kita akan cover receiver and optical detector chapter. Okay, dalam chapter ini, receiver terkandung ataupun receiver mengandungi few components lah. Komponen yang pertama ialah fiber to the light interface. Dan kita ada light detector, kita ada amplifier shape recorder dan kita ada output lah. Pada fiber to the light interface, kita akan cover beberapa optical detector yang sepatutnya kita tahu dalam fiber optic communication. Okay, pada minggu ke-9 saya telah upload beberapa video dan a few homeworks for you to do. Kalau yang tak tengok lagi, please do so, and the homeworks are like this lah. We need to watch the video and answer the following question. Question number 1 is to list the characteristic of a photodetector, and then explain how conversion of light to electrical signals happen. This is the most important parts in optical receiver. Okay, electrical detection ataupun signal detection is happen here. And then question number 3 is to list commonly used photodetector in communication. Okay, we have PIN photodiode, we have APD photodiode, and so on and so forth. And then the most important 3 photodiodes and how it works. So you should know how it works and you should know what it is. Okay. Homework number 2, kita ada photodetector. Okay, there are 3 types of photodetectors. Kita ada phototransistor, photodiode dan photoconductor. So what is the difference in between these 3 photodetectors? Okay, dia ialah satu komponen ataupun satu alat yang detects photo ataupun detects photon. Di mana photon tu ialah light lah. Then how we transmit or how we change the lights into electrical signals. And then in this homework, you should know the definition of it, and then the symbol of each of the components, and then how is the biasing happens. It's either forward bias or reverse bias, and where it is being used. So phototransistor is used in certain application. Okay, same goes to photodiode and photoconductors. Okay, the other video that I asked you to watch is the types of photodetector. Okay, as what you know, photodetector has been divided into 5 different types. Types number 1, photomultiplier tubes. Type number 2, vacuum photodiodes. Type number 3, PNPD, where PD stands for photodetectors. Then we have PINPD, and we have the last one is the APD. And then the most commonly used is these 3 types. We have PNPD, PINPD, and APD. The names for these photodetectors is given based on the materials that is being used for the construction of the photodetectors. Okay, for this type of photodetectors, you need to know how PNPD, PINPD, and APD works and what is the diagram looks like. Okay, luckily for those yang is not a visual learner, I also have upload chapter 5 part 1 PowerPoint slides. Okay, so what do you know about photodetectors? Okay, photodetectors are transducers that converts optical signals in terms of power into electrical signals in terms of photocurrents. So, what is the transducers? Transducers are devices that converts input energy of one form into output energy of another form. Okay, so by generating electrical current proportional to the intensity of the incidence optical lights. The higher the ataupun the brighter the lights, the higher the electrical current will be produced. Okay. And then we have photodetectors requirement. Each of the photodetector for each application should have the following requirement lah. The requirement number 1 is high sensitivity at the operating wavelength of the source. So kalau the punya sensitivity is not match the wavelength of the source or the wavelength of the transmitter, it will not communicate because they do have different wavelengths, so they cannot talk to each other. And then point number 2, short response times to obtain a desirable bandwidth. Okay, dia mesti respond dalam masa yang cepat. And then point number 3, minimum noise contribution. Then compatible size for efficient coupling and packaging. Okay, lagi kecil, lagi bagus, tapi must be more powerful. And then we have linear response over a wide range of light intensity. Okay, wide range of light intensity means that when we dim the light, so is it the photodetector could respond to the low light intensity. And then how about at higher light intensity? Okay, so would it be able to respond to the light lah? And then we have stability of performance characteristic, low bias voltage, and of course low cost. Okay, this is how photodetector works. It's just a PN photodiode like a normal LED, but how it functions as a photodiode as explained in the videos. Okay, same goes to here where photo detection principles, how it detect lights and convert the lights into electrical signals. Then you have detectors. Okay, same like the homework. Okay, second part of the slide is about the detectors. Okay, we have photodetectors, photodiodes, and phototransistors as what you do in homeworks. Okay, the following slide will help you to complete the tables, and there are some information here that you can use to fill up the tables. Okay, please take note that the spelling is wrong here. Okay. Okay, this is an important parameter of photodiodes. We have three important parameters. Number 1 is quantum efficiency. Then we have responsivity and rise time. Quantum efficiency of a photodiode is defined as a capability to convert light energy to electrical energy, expressed as percentage. Okay, the formula is given by eta equals to number of electron hole photo generated pair divided by number of incident photons. So this is the formula for quantum efficiency. Okay, the other important parameter is the responsivity. Okay, we look at what is the responsivity definition. Okay, the responsivity of silicon photodiode is a measure of sensitivity to light. Okay, in general, it is defined as ratio of photocurrent IP to incident light power P at a given wavelength. Okay, responsivity is given by IP divided by light power, incident light power, equals to NQ over HV. Okay, the relationship between quantum efficiency and responsivity is given by R equals to theta lambda divided by 1240. Okay, the other important parameter of a photodiode is the response time. Okay, you still remember this? Fall time and rise time. Okay, a photodetector response times is important because it defines the bandwidth of the receiver. Okay, where we have B equals to 1 over 2 pi RT times CT. Okay, there are three factors that define the response time. Okay, we have number 1, transit time of the photocurrent in the depletion region. Okay, and then we have diffusion time of a photocarrier outside depletion region, and then we have RC time constant of the circuit. This is the important factor that define the response time of a photodetectors. Okay, based on the three important parameters of a photodiode, Now we are able to do exercise number 1 and exercise number 2. This is a very direct to the point exercise where we have where we need to replace the values given in the formula. Okay. For exercise number 1, we have a photodetector which has responsivity of 0.5 A over W and a bandwidth 3 dB bandwidth of 500 MHz. Okay. The question is how much current is produced by photodetectors if the incident optical power level is given by minus 43 dBm. Okay. We have this formula. Okay. R equals to IP over P naught, where we need to find IP, we have R, and we have P naught. Okay. So what we have to do is to replace the values given in the formula, where do we have R and we have P. So we can easily find IP. So IP is given by 25.06 nanoampere. For exercise number 2, a photodetector which has responsivity of 0.5 A over W and a bandwidth 3 dB bandwidth of 500 MHz, the same question, but this time we need to find the rise time of a photodetectors. Okay, in order to solve this question, you need to know a new formula. Okay, the new formula is we have F3 dB equals to 0.35 divided by rise time. So 0.35, and then we know the 3 dB bandwidth. So replace the values given in the formula. We have 0.35 divided by 500 MHz. So we get the rise time is 700 nanosecond. Okay, please remember this formula as well because it is not given in the previous slide. Okay, for types of photodetector, okay, now you have to recall back these 3 important photodetectors. Okay, how it looks like, what is the construction layers, and how it works. Okay, these two works the same and the parameter is the same. Okay, how we measure the quantum efficiency, the responsivity, and the rise time is direct to the point. But for APD, it is a very special photodetector. The 3 parameter is still the same: quantum efficiency, responsivity, and rise time. But the formula is quite different. Okay, for calculating the responsivity of APD, we need to consider the multiplication factor or a gain factor. Okay, denoted by capital letter M. Okay, M for all carriers generated in the photodiodes. So it's defined by this formula. Okay, so same goes to responsivity of APD, where we need to consider the multiplication factor. Okay. Okay, exercise number 3 to exercise number 5 is an example how we calculate the important parameter of an APD. It's either you need to calculate the responsivity, quantum efficiency, or the response time. Okay, please look at it and try to solve it. Okay, although the solution is given, try to do it yourself first and then check with the solution. Okay. Okay, if you have any question regarding exercise number 3 to exercise number 5, we'll discuss it when we meet next time. Okay, we have covered 3 important characteristics of a photodiode so far, which is quantum efficiency, responsivity, and rise time. So we have another 2 important characteristics of a photodiode or of a receiver, which is known as signal to noise ratio. Okay, normally signal to noise ratio is being used to define the quality of a signal in a system. Okay, the formula is given by 10 log 10 signal to noise, or we have 10 log 10 signal minus 10 log 10 noise. Okay, the last characteristic is defined as bit error rate or BER. This is related to signal to noise. So signal to noise is in analog, but we have bit error rate is the ratio for the digital signal. Okay, how many bits or how many error that we transmit over transmitted bits. Okay, to summarize this chapter, we have a block diagram of an optical receiver where we have three important blocks: the front end part, and then the linear channel part, and we have data recovery part. Okay, at the front end part, we have two types of front end circuit. It's either trans-impedance front end or the high impedance front ends. Okay, the decision on which front end to use is depend on the application. Then we have a photodiode. Photodiode, we have three important photodiode: the PN photodiode, PIN photodiode, or APD photodiode. Okay, which photodiode to use is also depends on the application. Then we have the preamplifier. Okay, preamplifier also depend on the front end. So either we use trans-impedance or high impedance front end, so it will affect the use of the preamplifier. And then we have linear channel. We have another type or another stage of amplifier. Okay, and then we have filter to filter out the noise from the circuit. Okay, the last block of optical receiver is the data recovery part, where in this part we have clock recovery and decisions before the data can be used for further signal processing. Okay, this is the equivalent circuit for receiver front ends, where we have A is the high impedance front end and B is the trans-impedance front ends. Okay, now we are going to look at the impairment of a real receiver. Okay, in this real receiver, we are going to have a noise. Okay, noise in a receiver is coming from thermal noise and short noise. Okay, depends on the use of the amplifier and the photodiode. Okay, then we have dark current and the timing filter. Okay, these three important points will affect the signals received at the receiver. Okay, dark current or ID is known as the noise current generated by a photodiode in the dark. Okay, the current which is generated when there is no light at all. Okay, it is caused by thermal generation of free charge carrier in the diode, and it's also known as a reverse leakage current. Okay, to summarize chapter 5, I think we have covered a block diagram of fiber optic receiver, where we do have three important parts. Part 1, front end, which consists of photodiode and preamplifier. And then we have linear channel, consists of amplifier and filter. And the last part is data recovery, where we have clock recovery and decision circuit. And then we have photodetectors. We have three types of photodetectors: PN photodiode, PIN photodiode, and APD photodiodes. Okay, for the photodiodes or the photodetector, what you need to know is how it works and what is the block diagram of the photodiode. And then the most important part is the characteristic of the photodetector or characteristic of the receiver. Okay, where we have 5 important characteristics. Characteristic number 1, quantum efficiency. So what is the definition of quantum efficiency and the formula for it? Characteristic number 2 is responsivity. So what is the definition and the formula? Rise time, and then signal to noise ratio and bit error rate. And then finally, we have covered factor that causes signal impairment in photodetector or signal impairment in the receiver. And not forgetting the 8 important points of photodetector requirements. So what is the requirements for photodetector? There are 8 points. Okay, that's all for today. So hope to see you next time in class. Okay, thank you very much. Bye.